Okay, in our third video and final video for the day, we are talking about reference angles. So as I mentioned at the very end of the second video, a reference angle is basically a positive angle formed between a terminal ray and the horizontal axis. It is always between 0 and 90 degrees or 0 and pi halves radians if we're dealing with radians. The important thing here is that the angle is always going to be formed between whatever the terminal ray is and the horizontal axis, not between the ray and the vertical axis, always between the ray and the horizontal axis. So if you were, and it's denoted by this theta with a little apostrophe, which we call prime, theta prime. So the easiest way to determine the reference angle usually is by sketching it. Eventually, when we do this with slightly bigger angles, you may not necessarily be able to. The angle given to us is 100 degrees. So 100 degrees is measured from here to here. That is a 100-degree angle, slightly past the 90 degrees, so slightly past the vertical. But the reference angle is the shortest distance between 0 and 90 degrees between that ray and the horizontal. Well, that happens to be over here. And the easiest way to know that is that this is 180 degrees. So if I took a 100-degree angle, the difference between that 100-degree angle and 180 is 80 degrees. And again, always double check to make sure that your reference angle is between 0 and 90. If you tell me that a reference angle is 95 degrees, that's wrong because it's greater than 90. So make sure that it is between that. If you do it in terms of radians, same general idea. The angle 4 pi thirds is measured from here to there. But again, the distance that we are looking for is the shortest distance from the ray to the closest horizontal. Well, that closest horizontal is pi. So we're going to take this angle 4 pi thirds and say, okay, what is its closest first quadrant equivalency? Now, the actual way you would do it is take 4 pi thirds and subtract pi. With radians, it's actually much, much easier because you are just looking for that first, again, non-reducible quadrant equivalency. So if I told you something was, and this isn't even like a normal unit circle thing, if I told you something was 11 pi twelfths, well, the closest to that's going to be pi twelfths. So it's really just going to be 1 pi over your denominator typically. So again, you would normally take 4 pi thirds and subtract pi to figure that out. To do that, you'd have to change pi into a common fraction, a common denominator, excuse me, of a fraction. So multiply pi by 3 over 3, and you would get 4 pi thirds minus 3 pi over 3, which then gives you 1 pi over 3, which is why theta prime is pi thirds. It's usually much easier to deal with in radians, believe it or not, than it is with degrees. All right. And then our last one tells us that our actual angle here is negative 45 degrees. Well, that just means that it went in a clockwise rotation. But again, that's only 45 degrees away from the closest horizontal. So theta prime is 45 degrees. So let me just give you an example of something on this paper, and you can write it down. So I'll give this, we'll do two examples real quick. So if we say that theta is, let's go with 5 pi thirds. And then the other one we're going to do is theta is, let's go with 460 degrees. So the 5 pi third ones, that's actually the easiest one. Because theta is 5 pi thirds, you're literally just going to look at the fact that this is something with a pi over 3 in it. Pi over 3 is going to be your theta prime. Now, 5 pi thirds would be someplace over in this quadrant right here. I think I have that drawn correctly as an approximation. But again, it would only be pi thirds away from here. 5 pi thirds would be all the way over around to there. 460 degrees, not quite as easy to do because that is definitely over one full circle. So we want to kind of put it into the terms of what it would be if it was one circle, or basically come up with its coterminal angle. We would do that by simply subtracting 360 degrees. So we would get a coterminal angle, which just means that it ends in the same spot, of 100 degrees, and that's by subtracting 360. So now I know that 100 degrees, well, that's just past 90, right? 100 degrees would be about right there. And then the difference between 100 degrees and 180 is 80 degrees, which is very much like the first example that we just did. So theta prime would be an 80-degree angle. All right, relatively short video. I think reference angles are not too difficult. Ultimately, what you are trying to find is whatever the first quadrant, or between 0 to 90, 0 to pi halves, equivalency would be of your angle. In other words, you are trying to find the coterminal angle to whatever your angle is, but in the first quadrant. I can't really say coterminal. That's not really the correct thing, because coterminal in the second and third quadrant won't work. But anyway, it's the closest you can get to the x-axis, or the closest angle to the x-axis in between 0 and 90, or 0 and pi halves. All right, that's good enough.